Hi, my name is Selena, and my project revolves around Parkinson's disease and deep brain stimulation as a treatment for Parkinson's. Parkinson's disease is one of the most common neurodegenerative disorders out there. It has symptoms such as rigidity, cognitive impairments, and tremors. Deep brain stimulation is one of the most well-known treatments for Parkinson's, and it relieves these such symptoms. However, it is still not clear why the therapeutic benefits of deep brain stimulation still vary among PD patients. So in this experiment, we aim to investigate brain network differences between candidates and non-candidates for DBS and how they change over time in both groups. We collected our data at the Tsinghua University database from an experiment consisting of Parkinson patients that are qualified for DBS, those are not qualified, and healthy groups as a control group. Their EEG and resting state functional MRI were collected, and we experimented with these data to reach our final results. First, we have data pre-processing, by which we use a lot of computer programs such as Brain Processation, Melodic, and ANOVA. And we especially inserted data into RS-fMRI pre-processing, which was carried out by the fMRIB software library. These individual images were processed using Melodic into independent components. ANOVA models are also common throughout the experiment because we observed the differences between PD patients and healthy controls at baseline this way. And then we move into the data analysis. We used the results from pre-processing and inserted them into computer programs such as NBS, network-based statistics, that compare functional connectivity between groups, longitudinal MRI analysis, correlational analysis, and etc. All of the models presented in this presentation are results after experimenting with parameters and variables. In this graph, for section A, we demonstrate the difference of nodal strength and local efficiency of different groups at a lower network level. And for section B, I remembered using NBS and ANOVA to generate the data for demonstrating the connectivity and networks within certain parts of the brain of the patients. For the second model, I demonstrate the functional connectivity change in certain parts of patients' brain over time. And as you can see, there are distinctive patterns represented by the red and purple graphs above. Section A, B, and C each demonstrates a different correlation. And lastly, in this graph, we correlate symptoms of Parkinson's to the different sections of the brain of the different groups, acknowledging the passage of time. To conclude, my experiments suggest that graph analysis and connectomic represent a suitable approach to establish qualification of DBS in PD patients. In addition, from an experiment, we determined that routine brain MRI with network analysis benefits the diagnosis of Parkinson's and qualification of DBS. And lastly, we discovered that certain features of RS-fMRI and EEG fMRI, such as detecting hyperconnectivities, show potential signals for Parkinson development, which encourages patients to seek DBS surgery at a suitable time.